On to part C, which gives us root 11 minus 1 quantity squared. Again, you got to think of this like polynomials. If you were squaring a binomial, if you were squaring something that has a plus or minus in the middle, you cannot put the square to each term. You have to write it out. Okay, there's no shortcut here. You have to write root 11 minus 1 times root 11 minus 1. And then once again, you have a foiling situation, right? Because you have a difference of radicals times another difference of radicals. Okay, so you're going to do root 11 times root 11. You're going to do root 11 times negative 1. Negative 1 times root 11. And then finally, negative 1 times negative 1. So let's write it all out. We have to do root 11 times root 11. So root 11 times root 11. Then we have to do root 11 times negative 1. So minus 1 times root 11. Then we have to do negative 1 times root 11 again. So minus 1 times root 11 again. And then finally, for our two last terms, we have to do negative 1 times negative 1. So plus 1. Let's finish off any multiplication that we can. Root 11 times root 11 is going to be root 11 times 11. But we can simplify that right away because the square root is going to take that pair of factors and give you back a single factor outside of the square root. Okay. So root 11 times root 11 is just 11. Next we have minus 1 times root 11, which is minus root 11. We have minus 1 times root 11 again, so minus root 11 again, plus 1. At this point we've done all the multiplication, but we haven't collected our like terms. Okay. We can't simplify root 11, but that's okay, we don't need to. This negative root 11 and this negative root 11 will collect. And then also, this positive 11 whole numbers and this positive 1 whole number will collect. So we end up with the 11 plus 1 is 12. The negative root 11 minus root 11, remember there's little 1's out in front of here. So negative 1 root 11 minus another 1 root 11 is altogether minus 2 root 11's when you collect the like radicals. So that's the simplified result for the product of root 11 minus 1 times root 11 minus 1. So for part D, we have another binomial, right? Another difference of radicals times a binomial, a sum of radicals. So we're going to use the same strategy. We'll FOIL. The first terms here need to get multiplied. The outer terms here need to get multiplied. The inner terms here need to get multiplied. And the last terms here need to get multiplied. So, like before, let's write it all out. We're going to end up with root 6y times root 6y, right, plus 7 times root 6y from the outer terms. Now be careful because on the inner term you have a minus 7, so this is going to be minus 7 times root 6y. And then finally the last terms, negative 7 times positive 7 is negative 49. So let's continue multiplying out these radicals here. This is sort of going to be like what happened with the root 11 times root 11 in the last example. Here we end up, when we multiply underneath the square roots, we end up with root 6y times 6y. But the square root operation is then going to take that pair of factors and give you a single one outside. So the pair of 6's becomes a 6 outside the square root, and the pair of y's becomes a y outside the square root. So root 6y times root 6y ends up giving you just 6y. Now, this is actually interesting here. We have a positive 7 root 6y minus 7 root 6y. So we can't simplify those square roots, but we can collect them. Altogether, positive 7 root 6y minus 7 root 6y, when you collect like radicals, is going to be 0 root 6y, right, plus 7 minus 7. And 0 root 6y is just 0. So we're not even going to write anything for these. But we do still have a minus 49 tagging along. Now that's really cool because if you notice, we started with two radical expressions, but because of the structure of the expressions, because they were exactly the same except one had a minus and one had a plus, the middle terms ended up canceling out. And in the very end, there were no square roots left at all.